Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics 5054. And today we are in this video, we are going to work on the new topic which is added into the Cambridge syllabus. And the name of the topic is momentum. In this video, we are going to learn about the momentum, impulse, resultant force, and the principle of conservation of the momentum. So the main focus point of this lecture will be define the momentum, impulse, and resultant force and use the correct equations to calculate them. Solve simple one-dimensional problems using the principle of the conservation of the momentum. So this is the main topic today, very important video because this is the new topic which has been added into the O levels paper. The book I am using, which is showing up on your screen, that book is Cambridge O levels physics. The name of the book is Cambridge O levels physics, and it is written by Heather Kent and Tom Duncan. So let's start. So when a tennis ball is struck by a rocket or a gas molecule rebounds from the side of its container, their behavior can be understood by introducing the concept of momentum. Momentum is defined as the product of mass and velocity. In a collision, momentum is conserved unless there are external forces acting, such as friction. You can demonstrate conservation of momentum with a Newton's cradle. The last ball in the line moves off with the same velocity as the first. Collision generally occurs over a very short interval of time. The shorter the time interval, the greater the force on the bodies involved in the collision. Crumple zones at the front and rear of a car help to prolong the collision time and reduce the force of an impact. So, momentum is a useful quantity to consider when bodies are involved in collisions and explosions. It is defined as the mass of the body multiplied by its velocity and is measured in kilogram meter per second, kg meter per second, or Newton second. Momentum is equals to mass multiply velocity. In symbols, momentum is equals to P equals to mv, and the change in momentum is equals to change in momentum is equal to change in the product of mv. A 2 kg mass moving at 10 meter per second has momentum 20 kg meter per second, the same as the momentum of a 5 kg mass moving at 4 meter per second. So here the key definition which you should remember is that momentum is mass multiply velocity. So here we have practical work, collisions and momentum. Safety. Take care when rolling the trolley down the ramp. Ensure it is clear at the bottom of the ramp and use a side barrier to prevent the trolley from falling onto the floor. Figure 1.6.1 shows an arrangement which can be used to find the velocity of a trolley before and after a collision. If a trolley of length L takes time t to pass through a photo gate, then its velocity is equals to distance divided by time, and that is L divided by t. Two photo gates are needed, placed each side of the collision point to find the velocities before and after the collision. Set them up so that they will record the time taken for the passage of a trolley. A ticker tape timer or motion sensor placed at the top end of the runway could be used instead of the photo gate if preferred. Attach a strip of Velcro to each trolley so that they adhere to each other on collision and compensate a runway for friction. So you see, here we have a ramp, here we have a trolley, here we have another trolley, and this is a ramp. So when I will let this trolley go, here we have interrupt card on the trolley. So here we have that sensor. When this trolley will pass from this gap, this card will stop the path of the light, and for this for this length, the when this trolley will be going downward, so the path of this light will be stopped. It will be blocked actually. So and this photo gate will measure how much time, for how much time the light has been blocked. Then this trolley will hit this trolley, then both these trolleys will, means they are collided, and then they will both go in this way downward. So now this trolley will block this path, and you know the length of this card, and from this device, the photo gate will tell you for how much time this light has been blocked. So you can calculate from here. You know the length of the card, you divide it with the time for which the light is blocked from the with the help of the photo gate. You will be able to tell the speed of the trolley before the collision. And when these two trolleys will be joined here after the collision, and they will pass from here, you divide the length of this card with the time the light is blocked, and you will get the velocity after the collision. So this is the basic. Let me show you one thing. Here we have used different words. This is the Velcro tape. I hope from the diagram you understand this. This is the Velcro tape, and he said that on the trolleys put this Velcro tape. So after the collision, they remain attached to each other. So this is called the Velcro tape, and this is the photo gate. Photo gates are a timing device that measure times of the changes in the state of an infrared beam that is blocked by a flag of known length, as well as the time the beam is unblocked. Okay, using the flag length and the block time, students can calculate speed. I hope you understand both these words. Okay, then we have place one trolley at rest halfway down the runway and another at the top. Give the top trolley a push, it will move forward with uniform velocity and should hit the second trolley so that they travel on as one. Using the times recorded by the photo gate timer, calculate the velocity of the moving trolley before the collision and the common velocity of the both trolleys after the collision. Repeat the experiment with another trolley stacked on top of the one to be pushed so that two are moving before the collision and three after. Copy and complete the table results. So here you have the mass, or you can say number of trolleys, velocity, and momentum. And this is before the collision and after the collision. Now when the trolleys are attached to each other, then their mass, their velocity, and then their momentum. So by using this formula, m1 plus m2, put brackets around it, and then multiply it with the velocity. Do the You will observe the results will be same, I think. Do the results suggest any connection between the momentum before the collision and after it in each case? Why is it necessary to tilt the runway slightly before taking measurements? Calculate the momentum of a 2 kg trolley moving with a velocity of, okay, so 2 kg trolley, if you want to find out the momentum, the velocity is given, the mass is given, simply multiply mass and the velocity with each other. You will be able to calculate the momentum. You can practice these questions. Here we have calculated the momentum of a trolley moving at a 3 meter per second and having a mass of 200 grams, 500 grams, 1 kg. Here the only problem is that the units are supposed to be in kg. For example, there the mass is given in 200 grams. So first of all, convert it into kg and then multiply it with the velocity. Here in this question, the velocity units are not good. It is 5 centimeter per second. First of all, convert it into meter per second. Okay, so in that formula where P is equals to mv, the mass must be in kg and the velocity must be in meter per second. Okay, so we have the conservation of the momentum when two or more bodies act on one another, as in a collision, the total momentum of the bodies remains constant, provided no external force acts, for example, friction. This statement is called the principle of conservation of momentum. Experiments like those in the practical work, which we just did, and we just read, in the practical section, work section, show that it is true for all types of collisions. So here the key definition is that the principle of conservation of momentum, when two or more bodies act on one another, the total momentum of the bodies remains constant, provided no external forces act. So here we have a worked example. Suppose a truck of mass 60 kg moving with the velocity 3 meter per second collides and joins with a stationary truck of mass 30 kg. The two moves off together with the same velocity v, which we can find as follows. So the total momentum before the collision, the momentum of this plus the momentum of this, its momentum will be 60 kg multiplied 3 meter per second plus its momentum will be 30 kg multiplied 0 meter per second. So that will be the momentum before the collision. After the collision, they both are joined together and they are moving with the velocity v. So the total mass will be after the collision 90 kg and the velocity is v. We don't know how much is that velocity. So that will be 90 kg multiply v. Now the collision before the momentum and collision after the momentum before the collision and momentum after the collision, and they both the momentums will be equal. So you equate both the momentums, and in this way you will be able to find out the velocity after the collision. Okay, so here we have total momentum before collision will be 60 kg multiplied 3 plus 30 kg multiplied 0, and that will be 180 kg meter per second. The total momentum after the collision is 60 kg plus 30 kg, that will be 90 kg multiply v. Since momentum is not lost, so the 90 kg multiply v will be equals to 180 kg meter per second. So the v will be equals to 180 divided by 90, and that will be 2 meter per second square. I hope that you have understood this worked example. Okay, then he says, now put this into practice. And now you can practice these questions yourself. A trolley of mass 3 kg moving with velocity 5 meter per second collides and joins with a stationary trolley of mass 2 kg, and the two moves off together with the same velocity v. Assuming momentum is not lost in the collision, calculate the value of the v. You see, this is the exact same question, only the values has changed. The second question is, a trolley of mass 5 kg moving with the velocity 5 meter per second collides with a stationary trolley of the mass 2 kg. The 5 kg trolley stops and the 2 kg trolley moves off with the velocity v. Assuming momentum is not lost in the collision, calculate the value of the v. You can practice both these questions, and you see these are the two situations, and if you practice them, that will help you. Okay, here we have explosions. Momentum, like velocity, is a vector since it has both magnitude and direction. Vectors cannot be added by ordinary addition unless they act in the same direction. If they act in exactly opposite directions, such as east and west, the smaller subtracts from the greater, or if they are the same, they cancel out. Momentum is conserved in an explosion such as occurs when a rifle is fired. Before firing, the total momentum is zero since both rifle and bullet are at rest. During the firing, the rifle and bullet receive equal but opposite amount of momentum. So the total momentum after firing is zero. For example, if a rifle fires a bullet of mass 0.01 kg with a velocity of 300 meter per second, so the forward momentum of the bullet is its mass multiplied its velocity, that is 0.01 kg multiplied 300 meter per second, and that will be 3 kg meter per second. Backward momentum of the rifle, the backward momentum of the rifle will be 3 kg meter per second. If the rifle has a mass m, it recoils. Recoils mean kicks back with a velocity v such that the mv will be equals to 3 kg meter per second. Its momentum will be equal to the momentum of the bullet. So the taking m equals to, for example, the mass of the rifle is 6 kg, then the v will be equals to 3 divided by 6, and that will be 0.5 meter per second. So the rifle will recoil with a velocity of 0.5 meter per second. It's a very, very important thing. So then we have rockets and jets. If you release an inflated balloon with its neck open, it flies off in the opposite direction to that of the escaping air. In the figure 1.6.3, the air has momentum to the left and the balloon moves to the right with equal momentum. This is the principle of rockets and jet engines. In both, a high velocity stream of hot gas is produced by burning fuel and leaves the exhaust with large momentum. The rocket or jet engine itself acquires an equal forward momentum. Space rockets carry their own oxygen supply. Jet engines use the surrounding air. So here we have a balloon, the air is coming out of it. So the air's momentum is in this direction. So the balloon's momentum will be in this direction. A deflating balloon demonstrates the principle of a rocket or a jet engine. Okay, so here we also have test yourself. What is the momentum in kg meter per second of a 10 kg truck traveling at 5 meter per second? Very simple question. You can practice it yourself. 20 centimeter per second. The only problem here is that the centimeter per second must be converted first into meter per second. The C part is that the velocity is 36 kilometer per hour. Here, the only problem is that the velocity first must be converted into meter per second, and then you can calculate the momentum. A ball X of mass 1 kg traveling at 2 meter per second has a head-on collision with an identical ball Y at rest. X stops and Y moves off. What is Y's velocity? So Y's velocity will be exactly 2 meter per second. A boy with the mass 50 kg running at 5 meter per second jumps onto a 20 kg trolley traveling in the same direction at 1.5 meter per second. What is their common velocity? So here just use the principle of conservation of the momentum, that the momentum before the collision and momentum after the collision is same. So you will be able to tell their common velocity. A girl of mass 50 kg jumps out of a rowing boat of mass 300 kg onto the bank with a horizontal velocity of 3 meter per second. With what velocity does the boat begins to move backward? Okay. So again, you use that principle that the momentum before and after, that's same. So I will try to make a video in which I can actually solve these questions, but right now I am more interested in theory. And okay, the force and momentum. If a steady force F acting on an object of mass m increases its velocity from u to v in time delta t, the acceleration a is given by, so you know the acceleration is change in the velocity divided by the change in the time. So that is v minus u, and final velocity minus initial velocity divided by the time taken. So substituting for a in F is equals to ma. You know the resultant force is equals to ma. So in the place of a, if you put this value, v minus u divided by delta t, so you will have this. So m will be equals to v minus u divided by delta t. So m will multiply with the v, m will multiply with the u. So you will have mv minus mu divided by delta t. So this is the final momentum. This is the initial momentum. Final momentum minus initial momentum divided by the time taken. We also have impulse. Impulse is equals to the force multiply the time for which the force acts on the body. So the impulse will be equals to force multiply change in time, and that will be equals to the change in the momentum. Impulse, remember this thing, impulse is the force, resultant force multiply the time for which the resultant force acts, and this is also equals to the change in the momentum, where mv is the final momentum and mu the initial momentum, and f delta t is called the impulse. Since f delta t is equals to mv minus mu, then that is equal to change in the momentum. We can write f is equals to delta mv divided by delta t, which means delta p divided by delta t, because p represents the momentum. So change in the momentum divided by the change in the time, that is the resultant force. And define the resultant force F as the change in the momentum per unit time, or we say rate of change of momentum also. Resultant force is equal to the change in the momentum divided by the time taken. This is another version of Newton's second law. For some problem, it is more useful than F is equals to ma. So the key definitions here are impulse, force multiply time for which force acts. Resultant force is the change in momentum per unit time. Okay, so we have sports, impulse, and collision time. A good cricketer or tennis player follows through with the bat or racket when striking the ball. Figure 1.6.4a, the force applied then acts for a longer time, the impulse is greater, and so also is the gain of the momentum and velocity of the ball. When we want to stop a moving ball such as a cricket ball, however, its momentum has to be reduced to zero. An impulse is then required in the form of an opposing force acting on a certain time. While any number of combinations of force and time will give a particular impulse, the sting can be removed from the catch by drawing back the hands as the ball is caught. You must have seen, if you see cricket, you know whenever they catch, when they catch the ball, they move their hand backward. So to remove the sting of the catch, otherwise it will hurt your hands. A smaller average force is then applied for a longer time. So here you have, let me show you this diagram. The cricketer is following through after hitting the ball. Okay, so here we have to reduce the force on his hands. This cricketer should move his hands backward as he catches the ball. So I think you all know when we catch the ball. The use of sand gives a softer landing for long jumpers. So here we have that figure. As a smaller stopping force is applied over a longer time, in a car crash, the car's momentum is reduced to zero in a very short time. If the time of impact can be extended by using crumple zones and extensible seat belts, the average force needed to stop the car is reduced, so the injury to passengers should also be less. So here we have a diagram which says sand reduces the athlete's momentum more gently. Okay, so here we have test yourself. You can practice this question. A force of 5 Newton is applied to a cricket ball for 0.02 seconds. Calculate the impulse on the ball. And you know, impulse on the ball is F multiply T, the change in the momentum of the ball. The impulse is equals to the change in the momentum. In a collision, a car of mass 1000 kg traveling at 24 meter per second comes to rest in 1.2 seconds. Calculate the change in the momentum of the car. So you will have mv minus mu. The final velocity is 0. The initial velocity is 24 meter per second. So v value is 0, u value is 24 meter per second, and the time taken here is 1.2 seconds. For the change in momentum will be mv minus mu. You can calculate the momentum. The steady stopping force applied to the car, that is change in momentum divided by time. The force is change in the momentum divided by. You can do it this yourself. So the revision checklist for this topic is, after studying the topic 1.6, you should know and understand the following: the relationship between force and rate of change of momentum, and use it to solve problems. After studying the topic 1.6, you should be able to define momentum and apply the principle of conservation of momentum to solve problems. Recall that in a collision, impulse is equals to force multiplied delta t, and that is equals to change in momentum, and use the definition to explain how the time of impact affects the resultant force acting on a collision. So here we have exam style question. You can pause the video and you can solve these questions for your own practice. So here we have question number 2, question number 4, and so let me reduce the size so you can see them together. So here we have the questions. You can pause the video and you can take your time and you can solve these questions yourself. So my dear students, we are done with this chapter. This chapter I have used the book Cambridge O-Levels Physics, written by Heather and Tom Duncan. And we talked about momentum, impulse, resultant force, principle of conservation of the momentum in one dimension. So thank you very much for taking our time and watching this video. This is the new topic which has been added into the Cambridge O-Levels Physics 5054, and this will be tested from the exams which are starting in the May-June 2023. The questions which were there for practice, please practice those questions, and they will help you to master this concept, because in the paper you will find 1 or 2 questions from this topic. So thank you very much. I think that it's a great blessing for me that I can make these videos and I can touch the life of so many students around the globe. And I thanks all my students who are watching these videos. And I'm very sorry because I'm unable to answer your comments. But the time I have, I am making these videos to help you to improve your physics and make you understand these concepts and make the study easy for you, for your parents, for your teachers. If you like this video, please share the link of this video with your teachers, with your junior students, with your seniors, with your class fellows. And thank you very much. Have a good day. God bless you all.